Today, it's a great pleasure that Neil Leach is going to give the opening speech for the graduation exhibition of Yaşar University Faculty of Architecture students. Before we hear from him, I would like to invite Professor Meltem Gürel, Dean of the Faculty of Architecture, to deliver the opening speech for this exciting event.
Hoş geldiniz. Dear colleagues, dear students, dear guests, as we are closing the academic year and getting ready to graduate our class of 2024, we are very excited to be holding our graduation exhibition. And with that, we are honored to be hosting our distinguished speaker, Professor Neil Leach. Professor Leach is known for his work on AI and architecture. Now, this AI term is very new to a lot of us. Most of us did not know much about it. We heard about it, but we really didn't know what it meant. We're still trying to discover what it is and how it's going to impact our lives. All we know is it just happened very suddenly and it spread very quickly. Therefore, there are a lot of questions on our minds about AI and how is it going to change our lives and education in general. As educators, as academicians, and as professionals, we wonder how AI will shape our lives, will change our lives and the built environment. We are really wondering how it's going to impact architectural education. Are we going to instruct the same way, or do we have to change methods of teaching? We suspect nothing is going to be the same as before. It has already changed, so we really wonder about the impact of it in academia. We are wondering if AI is a tool, merely a tool, or is it something more than a tool? How is it going to develop, and how is it going to take its place in our curriculums and in our instruction? So with such questions in mind, we opened this academic year with a workshop on AI way back in the beginning of the fall semester. And we brainstormed how we could integrate AI into our curriculum and into our teaching. Again, with similar questions on mind, now we are closing the academic year with a lecture to be delivered by our honorary guest speaker, Professor Leach. Thank you for accepting our invitation and being here with us at Faculty of Architecture at Yaşar University. We are very happy to be hosting you.
Thanks to Professor Meltem Gürel for her speech. Now, it is my distinct honor to introduce our keynote speaker, Professor Neil Leach. We are privileged to have him share his wealth of expertise and insights in his speech titled Alien Intelligence, an Introduction to AI for Architects. To facilitate the speech, I'm also honored to invite Professor Ahenk Yılmaz to the stage as the moderator.
So, good afternoon, everyone. Welcome, first of all. I would like to take this opportunity to thank all of you for attending the opening of our graduation exhibition and for sharing our excitement at this important milestone in our students' academic lives. At Yaşar University Faculty of Architecture, we are committed to fostering an intellectual, ethical, and supportive learning environment. Our vision foregrounds critical reasoning, creative problem solving, and a design-centered approach. We strive to foster cutting-edge studies enriched by interdisciplinary connections to address the issues faced by contemporary society on both local and global scales. As we stand on the brink of a new era, where new generative technologies are transforming how we design, build, and inhabit our environments, AI comes forward as one of these important contemporary issues, advancing each and every day, not just as a tool, but as a game changer that promises to redefine the boundaries of our profession. So today's speech aligns perfectly with the vision of our faculty, as it will address the transformative impact of artificial intelligence on architecture. We are privileged to host a distinguished guest whose expertise and contributions have significantly influenced the intersection of architectural theory and AI technology. Our guest today, as well said, Professor Neil Leach, an internationally renowned architect, theorist, and educator. With an impressive career spanning several decades, he has held esteemed academic positions at institutions such as Harvard University, the University of Southern California, Cornell, SCI-Arc, and the AA School of Architecture in London. He currently directs the Doctor of Design program at Florida International University, and he is the co-founder of Digital Futures. Moreover, he is a former researcher for NASA, where he developed 3D printing technologies for the Moon and Mars, and a member of the Academia Europaea, Europe's leading academy. He has authored and edited numerous influential publications, translated into 8 different languages, including the translation of Leon Battista Alberti's On the Art of Building in 10 books, published by MIT Press in 1988. He is currently exploring the critical role of digital technology and artificial intelligence in shaping contemporary architectural practice. His most recent books include Architecture in the Age of Artificial Intelligence, published by Bloomsbury in 2022, and Machine Hallucinations. So, without further ado, please join in welcoming Professor Neil Leach to the stage.
Thank you for the introduction. I can't help feeling that somehow, with the number of female, the extraordinary number of female faculty here, somehow this has been directed in a very enlightened way. If there are 2 disruptive things in the world today, I'd say it will be COVID and AI. And during COVID, we saw how various female leaders, such as Angela Merkel, took a far more responsible role than I think some of the male leaders. Anyway, I think the future is definitely female, and I'm sure that the National University is in good hands. Let me briefly say that Digital Futures is the organization which I helped to found, and we have a Turkish language channel, and we're having various tutorials in Turkish in July. If you follow me on Instagram, you'll see all information about that. That's very important for us to not just have English, but to have many other languages as well. But today I'm not going to talk about the practical aspects of AI. I will refer to them in many ways, but more to give you an overview. And I think there are lots of issues that have been raised in those introductory remarks, especially about the role of AI in education, that need to be taken very seriously. And I think it's really good that you are taking them seriously, because for sure it's going to be a huge disruptor, AI, in our future. Let me start by with the backdrop of these images, and I'm sure many of you have been using Midjourney, DALL-E, LookX, and so on in your work. I've been exploring as well. I mean, literally just to see what the tool can do. And I'm not sure that they're good. What I would say is that in some senses, these are merely superficial 2-dimensional images, and they have a certain limited value. What will, I think, change the discipline of architecture will be something else. It'll be software that's be coming out very shortly. It will radically overhaul how we approach design. Nonetheless, there is something quite interesting about what these platforms can do, these diffusion models, Midjourney, DALL-E, and so on. And I'll refer to that later. But maybe I could just outline my own approach towards AI, which I've been working on since, I guess, about 2017, and before that, swarm intelligence. I'm every day amazed. I mean, literally every day amazed by what AI can do. And it changes on a daily basis. But I'm also every day more and more terrified by AI, by what it can do. I started writing a book, I think it was about 2008, 2019, I'd begun working on it. And I'd spent the summer working just on that book. And I felt compromised at the very end of the summer because I felt like I was working on something that was both amazing and terrifying at the same time. It was amazing because it is amazing, and terrifying precisely for the same reason. And I felt that I felt a bit like Elon Musk, who is both using AI for Tesla, for SpaceX, and for other enterprises, but warning us that it could be the end of civilization. I don't think it's going to be the end of civilization at all, but nonetheless, I felt compromised. So I wrote to my publishers, Bloomsbury. They're the guys who publish Harry Potter. They're based on Bedford Square near the AA. And I said, could we split this into two different books, two separate books? One with a white cover, like the angel, the good side of AI, and one with a black cover, like the devil, the dark side of AI, the Black Mirror episode version of AI. And they agreed. And the first one has come out, came out on the 16th of December, 2021. And the second one is, the second edition of that has been, I delivered the manuscript about 2 months ago, and I'm hoping it's going to come out as soon as possible. And anyway, and I had hoped to put the black one off for some time, but it became more and more obvious to me that actually the future is upon us earlier than we thought. So I'll probably have to start soon. But let me just say that there's nothing evil about AI. To my mind, although it does change the way that we operate as a culture, it is just a tool. And I think, like any tool, it depends on who is using it and for what. It's a bit like let's say, a kitchen knife. I can use a kitchen knife to cut up my vegetables. I could also use it to murder someone. So it's really a question of who's using it and for what. Nonetheless, it is the very capabilities of AI, the extraordinary capabilities of AI, that I think are the things that are, in some senses, worrying. So today's presentation, I want to give you a bit of both books and explain what AI is all about. And this is going to be, I'm a theorist by training, but this is going to be largely about information about this world. There is a whole domain, I would say, of theory that is absolutely fascinating. Neuroscience, especially, there's some extraordinary new ideas. And I think we're in a moment of probably the most exciting one in my career. I started teaching in the 90s when we had Zaha Hadid designing amazing buildings. We were talking about Derrida and Deleuze, and we had CAD, the first version of computer-aided architecture. And now something more extraordinary is happening, absolutely extraordinary. Anyway, first of all, I want to talk about what is AI. We all use the term AI, but I'm not sure so many actually know what it means. Secondly, I want to talk about a brief history of AI. I bought my house in Cambridge from Stephen Hawking, who wrote the book, A Brief History of Time, so it kind of means a lot to me. Thirdly, how can we use AI in design? And fourthly, who's afraid of AI? I am. Okay, so what is AI? I mean, the shortest description, shorthand description would say AI is like a digital brain. It's not a digital brain, but it's like that. And I quite like this description, which I used in my book by Margaret Bowden. Research in AI seeks to make computers do the sorts of things that minds can do, because it connects basically computers to brains. And with neural networks, that's the most important thing, connection to make. But there are two problems with this comment. I mean, well, it's basically out of date. And there are two problems with it. Firstly, AI can do a lot more than the human mind can do. And we already know that. ChatGPT knows 10,000 times more than anyone in this room, including the dean. It is extraordinary how much it knows. And secondly, we have to ask whether or not AI needs to do all the things that the mind can do. So for me, I've got this slide was in here. This is the moment when I realized how amazing ChatGPT could do. And I think ChatGPT really was a wake-up call for all of us. And you probably remember it was launched on November the 30th, 2022. And that day, later that day, there was this match taking place in the World Cup, Brazil versus Croatia, which, and I'd hoped the Brazilians were going to win. They were leading 3-0, it was 3-3, and then they went to penalties. And this guy, Neymar, the top player in the Brazilian team, never got to take his penalty. That's why he's looking so upset. He was number 5 on the list. And my colleague, Angelica Poncio, my colleague in Digital Futures, who is Brazilian and also interested in AI, went to ChatGPT and said, who should have taken that first penalty? And it said, the best player should have taken the first penalty. So all of a sudden, I began to realize this could be incredible in giving us advice for all sorts of things. But the other thing question is whether or not AI needs to do all the things the mind can do. These are the 2 neural networks we're talking about. On the left-hand side, the neural network of the brain, and the right-hand side, the artificial neural network of AI. And I'll just mention that these things here, these circular things here, are called neurons, and they're connected by synapses, and the information is flowing from left to right, governed by the weights on the synapses, and they can be adjusted over time. And there are many of these. The hidden layers can be up to 5,000 hidden layers in deep learning. And it's tempting to think, because you're using the same terms, neurons and synapses, that these things are very, very similar, but they're not really. And that's why when I talk about AI, I use the term alien intelligence to stop you from anthropomorphizing it and thinking it's like human intelligence. But it's not. It's only loosely based on the brain. And the important distinction between the artificial neural network and the neural network of the brain is that AI is not conscious, it's not sentient, it's not self-aware. But then the question is, does it need to be? And increasingly there are people sort of saying, well, maybe not. You know, as far as I'm concerned, if a machine can do what it needs to do, if my toaster makes good toast, I don't care if it's conscious or not. If it does AI, if a computer can generate good designs, I don't care if it's conscious or not. But this is not what AI is, okay? If you use Midjourney, you type in AI, it'll give you a robot, but that's not what AI is. This is Sophia, the humanoid robot, that those working in the field are apoplectic about. They think Sophia's a complete con, a complete fraud. And certainly a robot doesn't have to be humanoid. But it's important to point out that Sophia is no more AI than a Tesla car is AI. It might be controlled by AI, but it is not AI. And if you want to think what AI is, don't think humanoid robot, think algorithms, think programming, think software. Think that's essentially what AI is. It's software, very sophisticated software, but software nonetheless. And so in the office of the future, we're going to be surrounded by AI, no question, but we're not going to be surrounded by humanoid robots. And I guess the point is that maybe a few months ago, fewer people would have known this, but we are already totally surrounded by AI. It's on our phones. Most of the apps on our phones are controlled by AI. AI is what filters out our spam on email. It's what finishes our sentences on Gmail. It's what identifies our friends on Facebook. It's what translates on WeChat, and so on and so on and so on. It's everywhere. But because it's software, it's effectively invisible. We can't really see it. So in my book, I make this comment. It is as though the Earth has been invaded by an invisible, super intelligent alien species. So a brief history of AI, and it is a really, really brief history. I mean, some people say it all goes back to antiquity. It doesn't. I mean, in fact, the real changes have only happened since the millennium. But this guy, Alan Turing, was probably the first person to conceptualize the connection between computers and intelligence. He died tragically in 1954 by suicide, possibly because he had been shamed by being convicted of lewd acts of homosexuality. And he never lived to the day when, in fact, the term itself was invented, which was in 1955 for an event that took place in 1956 in Dartmouth College in the States, where all the smartest guys in the world of kind of computing got together, including, this is Claude Shannon, a very famous computer scientist, Marvin Minsky, who's now maybe somewhat in disgrace, and they got together with the idea of trying to solve the basic problems in 2 years. That was the intention. They didn't do that. In fact, despite the hype, and there was a lot of hype about AI, it failed to deliver on many things. And in fact, in the first 50 years, when these characters got together again, as the survivors, as it were, in 2006 for the reunion, they had to admit that they'd achieved almost nothing, and they also they predicted they would achieve almost nothing in the next 50 years. Part of the reason, frankly, was that computers were not powerful enough, but there were a lot of competing approaches towards AI in those days. The dominant two were symbolic AI based on logic, and connectionism based on neural networks, which is what we use today. But connectionism had gone out of favor, and there'd been very little research done in that area, largely due to a book by Marvin Minsky where he trashes the whole thing. And that's a bit unfortunate, shall we say. But by 2006, by a curious coincidence, this was roughly the time when actually neural networks began to take off. And all of a sudden, things changed. And they changed largely down to this guy, Geoffrey Hinton, who is the kind of the good guy in the story. I'm sure there are going to be lots of Hollywood movies about this and soap operas about what's going on at the moment. But Geoffrey Hinton is the guy who he comes from a very distinguished family in the UK. His great-great-grandfather was George Boole of Boolean geometry fame. And he actually studied architecture in Cambridge for 2 days. And then he decided it wasn't for him. I've mentioned this to some colleagues, and one colleague at Foster and Partners said, he's smart. It took me 5 years to realize architecture is not for me. Anyway, he then moved into natural sciences, and he became a kind of neuroscientist. He was interested in how the mind works, and he was convinced that the way to get AI to work was to model it on the brain. And he persisted. And the curious thing is, and much of the history of AI is completely accidental, actually. He wasn't really an AI person, but he accidentally fell into the field because some of his neural networks that he was doing to model how the brain worked actually worked. But basically, the thing that changed everything was the invention of GPUs, graphic processing units, which again weren't intended for computers. They were intended for the gaming industry, but they found out that actually they could make computers much, much more powerful and much faster. And that's what was the huge game changer in the field. So around 2006 and onwards, GPUs were invented about 2000. Things began to change, and we went through what is called the deep learning revolution. There are a number of reasons for this, apart from the improvements to the computers, but basically that was a huge difference. So if we think about deep learning, what we have today, we're talking about ChatGPT or Midjourney, DALL-E, and so on. This is basically deep learning. It's based on neural networks. It's based on connectionism. And you can see this has been a kind of subset of machine learning, which itself is a subset of artificial intelligence. So when we refer to AI, we're normally speaking about deep learning, but there's a huge difference between the two. I mean, if you imagine the difference between the very first sort of experimental car and a Tesla self-driving car, it's much far more vast than that. But these are the categories, and they're kind of nested inside each other. But deep learning is really what's led to the revolution, as it were. How can AI be used in design? Well, actually, this kind of overlaps with the last section, because it was actually this was a moment when people really began to realize how good neural networks can be. So in 2012, Fei-Fei Li, who's now based in Stanford University in California, one of the leading figures in AI, organized a competition to see how quickly you can recognize an image. And we all take it for granted now. We have facial recognition in our phones and so on. It's commonplace. But in 2012, it wasn't. We didn't have anything that was very good at anything like this. And in this competition, Geoffrey Hinton came along with his PhD students using neural networks. Now, imagine this was seen as an obsolete technology. It was a bit like using a steam engine. And they were astounded when Geoffrey Hinton when his team using these neural networks won by a huge margin. They kind of wiped the floor. And Fei-Fei Li, in her book, maybe she's exaggerating. She says this was like the world speed record was beaten by 100 miles an hour by someone driving a Honda Civic. I'm not sure that's right, but anyway, that was the way she put it. This was a huge shock, and all of a sudden, overnight, people said, well, of course, I always thought that neural networks were the way forward, and everyone changed. So 2012 was really when I think it really they began to realize. So what's happening here is that basically you're getting the pixels of this image are being processed through these layers, and eventually it ends up with some interpretation, normally never 100%, normally 99%, that it's a bird. Well, that was a huge breakthrough. But actually, the real holy grail for the world of computer science was to work the other way around, to start with the word bird or a concept and to generate an image or hallucinate or synthesize an image. And that was to happen not so long later when this was developed by a Russian scientist working for, engineer working for Google, who realized that you could simply just invert the network, or in other words, instead of going from left to right, go from right to left, and you could hallucinate this trippy image. And it's trippy because it's lost information about where to position things. But basically what's happening here is that you've got a neural network that's been trained on, I don't know what it's like serpents or something, and then dogs and maybe an oil lamp, and it reads that into everything it sees. So you get this image, which caused a sensation. And the first exhibition of AI generated art in San Francisco was curated by Blazer Guiriakos of Google, and this was really something that was a game changer. But that only took us so far. And the next step, which is I think the more important step, was the work of this guy, Ian Goodfellow, also in Canada. I should say that Geoffrey Hinton was at Toronto. He hadn't wanted to go to MIT because of the military funding, and so he went to Canada instead. But also in Canada, in Montreal, Ian Goodfellow was doing a PhD and went to a pub one night with his mates and was talking about an idea he had, and they seemed very enthusiastic. So he went back and wrote it up. And this is an idea of what are now called GANs, generative adversarial networks. And they're based on two separate networks, a generator here and a discriminator here. And what happens is basically the generator takes random noise and generates an image, a fake image, which then the discriminator judges against a training set. And if it's convinced, it accepts it. If it's not convinced, it's rejected. It's a bit like an art forger whose work is being judged by a critic. Anyway, in the process, the generator is trained to improve its act, and eventually you can take away the discriminator, and it will continually produce good images. But this led to a completely different, much higher level of production. A series of there's a whole zoo of different GANs, of which Style GANs is one of the earliest versions. And what you basically do, this was a very, very laborious process. You had to train a neural network on thousands of images. In this case, probably Hollywood models. And eventually, over time, it'll start producing something that is kind of, reasonably good. And there is actually a website you can go to, This Person Does Not Exist, where you can literally do that. Every time you refresh your browser, you get a fake person coming out. And of course, they are fakes. There's also a site, This Cat Does Not Exist, and you can generate cats. Well, meanwhile, architecture was way, way behind. In 2019, I teamed up with Patrick Schumacher, with Zaha Hadid Architects, shall we say, and with Refik Anadol, who is Turkish, of course. And I should say there are a lot of Turkish people very good at AI, not just Refik Anadol, but also Memo Akten and Güven Çözel, who's an architect in LA. And we applied I applied to curate the British Pavilion at the Venice Biennale, sponsored by Google. This was a dream team, 2019, and we didn't get anywhere. We were not even shortlisted. What we proposed to do was to do what that previous thing I'd shown had, but instead of generating faces, to hallucinate buildings. Anyway, Refik eventually took it upon himself to do it anyway. He got hold of all the images he could of the work of Zaha Hadid and trained a neural network, a version of Style GANs, and eventually something comes out of the computer that resembles the work of Zaha Hadid, even though Zaha Hadid was no longer with us. And in a second, you'll see what I think was the first ever GAN-generated image of, let's say, an architectural design, which is what we put on the front cover of this book, which is the first of a slew of books. The first one in English on AI and architecture came out in December 2021, was out of date by by July, I would say, and for reasons I'll explain in a moment. Meanwhile, there are other versions of GANs. This is Cycle GANs. This is the work of Daniel Bolojan, who's the great AI and architecture genius, I'd say, who trained with Zaha and works for Carl Pimmelblau and teaches at FAU. And he's using Cycle GANs. And Cycle GANs is where you're effectively breeding new results. You're playing one data set off against another, whereas the previous one was just a kind of like, let's say, interpolation. It was an averaging of a finite data set. When you start breeding, you could breed Zaha with, I don't know, orchids or something, and you can extrapolate and produce potentially new results. And this was really the state of the art in about 2001, maybe even 2002. And this is what we eventually, and you can see how it's kind of glitchy. It's not very good resolution and so on and so on. But we put it on the front cover of this book, Machine Hallucinations, which was the first which was I think the third book, an AD that we co-edited, which was out of date within about 3 months. I think it came out in April. By July, it was out of date. And it was out of date basically for this reason, for what you now know as AI, I guess, diffusion models, which operate in a very different way. They're not like GANs. They're trained, basically, it's a neural network, a generic neural network trained on a huge corpus of data, and all you do now, it works through a process called diffusion, which basically the image gets disrupted or corrupted, and then it's repaired. It's the process of reversed, and you get a new image. So it's nothing the same, nothing like the GAN, and it's also much easier to use. You haven't got to be a specialist computational expert, and the resolution on the whole is much better. And as you know, it's based on the logic of a text to image. And this one was quite startling in some sense because it was released by OpenAI, and this wasn't available to the general public. But in I think April, May, they were showing some of these images that were startling because this one had the prompt was an astronaut on a horse. Presumably there'd never been an astronaut on a horse before, but it's able to interpret what an astronaut on a horse would be like. And anyway, I was talking about this at the Architectural Association in London in May 2022, and I was saying, when are we architects going to wake up to this world that's about to change? And Patrick Schumacher was in the audience, and he said, we already have. And I didn't know this, but they've been working with Refik Anadol on using DALL-E 2. Refik had been given access to the tool before it was made available to the public, and they produced something that's clearly much better than that early work that they'd done with GANs. And I guess the rest is history. It was also, I guess, much better sense of 3D and materiality. And that's what you're using, basically. You're using diffusion models. And they've improved over time. They've got much better. I think the way that I see this happening, even though this is not what's going on with a diffusion model, the model of the GAN is kind of interesting because I think it suggests how we're operating. In fact, that model of the GAN is actually how we work anyway. I mean, you as students maybe are generating stuff, you submit some designs, and your tutor is looking at it, is the discriminator and telling you it's not good enough, go and do better work. That's kind of how we work anyway. But I think that we human beings are very good discriminators. If we taste a cocktail or smell a perfume, immediately we know if we like it or not. We're very good at that. Even with images, we can tell immediately. But I don't think we're as good at generating images as we like to think we are. I don't think we're as imaginative as we think we are. And what's happening, I think, is that these diffusion models are coming up with options we never thought of. What about this? What about this? What about this? You know, and basically expanding that field of possibilities. So I see these things as kind of prosthesis to the imagination, but it's basically improving what we can do. But it's improving because it's proving our weaknesses, which I think is our imagination. Anyway, that's not going to be the future of AI. I mean, they're nice tools to play with, perhaps, but that's not going to be the future. The future is going to really lies in some software being developed right now, and it's kind of appropriate in Yasha University, where there are so many females in charge here, to talk about Wan Yu He, who is, I think, the one person at the front here. She's actually, well, she's a doctor of design student of mine at Florida International University, and also a PhD student of mine in Tongji, and she's remarkable. she used to work for OMA, for Rem Koolhaas, and got so frustrated by the inefficiencies in the office. They were, when she was working first in Rotterdam, then in Hong Kong, and their offices in Hong Kong were based in Lang Kwai Fong, which is the nightclub area of Hong Kong. And they were kind of looking downstairs and seeing all these people going out to nightclubs, and they were working till 2 a.m. and working on weekends and so on. And when you thought there must be a better way of doing this, and that led to the foundation of XCool. XCool means ex-Koolhaas, and you probably know that OMA has a research branch called AMO, where you flip around OMA and get AMO. So LookX, which is the diffusion model, which is trained on architectural drawings, images, and architectural text, is basically the inversion of XCool. And LookX is important because the problem about Midjourney and DALL-E is they're not trained on architecture. They're just trained on generic images and so on. And there are certain terms that we use, such as, specification and so on, that are particular to architecture. So anyway, that's a huge development. But what she began to do back in 2016, when she set up her office, was to realize that you could do things that they were doing elsewhere. This is a website, a software that they developed called This Building Does Not Exist, where there are fake buildings, like there's fake people. They're just 2D images, they're not 3D, but this was the first step, I think, in the right direction. But the future is going to be something completely different. The future is going to be based, I think, on 3 things: on data, on automating the process of design, and on optimizing things. And in fact, it's going to be what they're working on, and the same in some senses applies to Autodesk, is a singular platform where, instead of having lots of different softwares, for example, if you're working with in Zaha's office at the moment, you might start with Midjourney, go into Maya, go into Rhino, go into BIM, and maybe something else. It'll all be on a single platform. It'll be on a single platform where everything is kind of embedded into it. So the notion of what the cost of things is going to be embedded into it. All the planning constraints, the building regulations are embedded into it. So you can't do anything else. You have to do what the software will allow you to do. And it'll be a much more controlled environment. It'll go all the way through to fabrication. But what you can see in this video is the kind of process of optimization. Here, this rectilinear form here has been broken down by a process of topological optimization to produce forms that are more like let's say, like the forms of Gehry, but which actually perform much better. This is based on wind comfort, but there are many ways there are many forms of optimization you could do: structural optimization, environmental, acoustic, and so on. And you can see that the forms that come out are very, very different to the initial forms. What makes this so important is not only did they win this competition, but they ended up building it. And I think this was produced 2 weeks ago. So this shows how things every day are changing. This is the first ever constructed example of a generative AI. I think this is the future. We'll get much more like this. Anyway, just to say, and I'm not talk very much about the profession, but since you're going out into the profession, you should be aware of these things. A recent study that was done by Harvard and MIT pointed out that there is a significant difference when you use AI over when you don't use AI. Not only can you produce better work, this one is based on quality, but you can also produce more and much more quickly. In other words, in the future, you won't be able to survive without using AI. When I was a student at Cambridge, we had a professor who told us we shouldn't use computers. That was stupid. We were unemployable. I mean, not totally unemployable, but you will need to know AI for the future, because that is going to dominate the way the office will be working. So this is the lesson, basically. If you don't use AI, you'll be sleepwalking into oblivion. You need to think about it. You need to be using this, because that'll be the tool that will increasingly dominate everything. So in the sense of, this is what now you've finished your degree, or some of you finished your degree. What you need to design right now is not another building, but your very future. Use that architectural imagination to think how you're going to survive in a world that's going to be changing more and more rapidly. Anyway, this is the Black Mirror side of things, which is a little bit terrifying. But So over the course of history, we've been pretty much unaware of what's been going on in terms of AI. It's been people in laboratories have been developing it, but it's only when in certain moments when there's been some event that's been hosted that we've really got a glimpse of what it can do. Ray Kurzweil predicted that by the year 2000, AI would beat the world chess champion. And in 1997, IBM's Deep Blue took on Garry Kasparov. Now, Garry Kasparov is probably one of the greatest chess players we've ever had. And of course, nobody expected him to lose, least of all Kasparov himself. But something else happened. Initially, Kasparov thought he'd been cheating. Anyway, it beat him. And eventually he thought it was a triumph for human beings because we developed AI, but he did make this comment. We just have to understand that everything we know how to do, machines will eventually do better than us. That's not to say everything at the same time, but for chess, forget it. You won't beat AI. It's a bit like competing against a calculator at arithmetic. You won't beat a calculator. So, however, that was back in 1997, and they did this by basically what's called expert systems. They just, through brute force, they trained a computer on all the known games of chess, and it worked. But a much bigger challenge was the game of Go, because I don't know how many played Go here, but Go is actually quite straightforward in terms of the moves you can make, but it is infinitely complicated because of the number of potential moves. There are more potential moves in Go than there are atoms in the universe. And that means that it's impossible to use the same expert systems. Indeed, if you put all the computers in the world together, they wouldn't have had enough computing power to operate. So what they had to do was shift to these new learning systems, this new neural network, the connectionism. That was the way forward. So this guy on the right is Lee Sedol. He was the Garry Kasparov of the world of Go, a real genius. And this system called AlphaGo was developed by DeepMind in London, whose CEO is Demis Hassabis. Anyway, something happened in this match that really astonished everyone, and it became a sort of a what they call a Sputnik moment, because the whole world, Sputnik was in, I think the Soviets launched a Sputnik in, I think, 1957, and suddenly the Americans woke up to the fact they were behind in the space race, and that's what led to the foundation of NASA and Apollo 11 going to the moon and so on. But this was a second Sputnik moment when the Go-playing nations in the world realized how incredibly powerful AI could be. There was something that happened. This is what Lee Sedol, a comment he made after game 2. Yesterday, in other words, after game 1, I was surprised. But today, i.e. after game 2, I am speechless. So what exactly happened in this match that made him speechless, and indeed everyone else in the world of AI and the world of Go? Well, it's almost like you can put it down to one particular move. In fact, there are a number of moves that are called slack moves, because it wasn't very clear until later on how strategically brilliant they were. But this particular one, it was really the one that stood out. And it goes down to this particular stone here that's known as move 37 in game 2. Now, it's been put on the 5th line, which is unusual because normally it's on the 4th or the 3rd line early on in the match. And everybody thought it was a mistake. They thought, oh, computer's useless. That's a glitch, rubbish. It'll never beat human beings, least of all Lee Sedol. But then 100 moves later, these two black stones there joined up with that black stone, and it won the match. It was as though AlphaGo had been thinking 100 moves ahead, which is truly astonishing. And this is just this is what the commentators thought about it. They thought it was a mistake.
From the Google team was talking about is this kind of evaluation value?
That's a very surprising move.
I thought it was a mistake.
So after the match, what Lee Sedol basically said is that it was being far more creative. I'm not sure it was being creative, but he said it showed us that moves humans may have thought are creative were actually quite conventional. It was operating at a far higher level. I think what is important about this particular move and the other moves is not this. I think the point is it was operating at a level we could not understand. We could not understand. So those of you who've got dogs, and there's a lot of dogs sleeping in the sun today, those of you who've got dogs know that dogs can smell or hear a much greater range of smell and of sounds and smells than human beings, much greater range. This is what AI can do, except it's in terms of intelligence. It is off the spectrum. We simply don't understand what it's doing. And the comment has been made by Mo Gaudet that in 10 years' time, it'll have an IQ of 1,600. We won't be able to understand what the hell it's doing. It's going to be way beyond us. Well, if you thought that was impressive, the next version, the next model was even more impressive. Not only could it play Go, it could play chess and many other games, and it beat AlphaGo by 100 games to 0. So AlphaGo 0 was much superior. But what was astonishing about it was that it wasn't taught the rules of Go, but it learned the rules of Go by playing a huge number of games against itself over 3 days through reinforcement learning. It learned by playing 3.9 million games of Go over 3 days. Now that sounds like a lot, right? 3.9 over 3 days. But when you think about it, it really is a lot. It basically means 20 games of Go a second. Now, how can you play 20 games of Go a second? This is a video of a hummingbird. I live in California. We have lots of hummingbirds. And this is admittedly a slowed up video of a hummingbird. But it's beating its wings on this video about 3 times a second. Now, imagine 7 times as fast. That is just incomprehensible. It's able to operate at this level. I think this was something we should have been paying more attention to, because this was it gave us a sense of what was to come. This, in some senses, is why people are now so terrified by AI, precisely because of the speed at which it operates and what it can do when not trained. So let me move on to this thing, which I think is really what we should be worried about in some senses, large language models. That doesn't sound very sexy, it doesn't sound very interesting, but this is what it's all about, large language models. Well, first of all, they're not large, they're gigantic. We're talking about neural networks trained on trillions of bits of information and billions of parameters. They are enormous. But what is really disconcerting about these things is that they're not so computationally advanced. They've got about 200 words of code, but they start developing what we call emergent capabilities. In other words, they start doing things they were never trained to do, and that's alarming. They start learning how to translate languages. They start learning how to write code, and no one has trained them to do this. Moreover, it is the size of the data that is dictating this. And the more the data, the more they're doing these things. Every year, the amount of data they've been trained on goes up by 10. That means in 2 years, 100 times. So we are seeing something a little bit scary where these things are doing things they've never been trained to do, and we don't know what the hell is going on. This led to a whole series of things when suddenly last year people started saying, this is a bit worrying. This is very worrying. Look what's happening. And Geoffrey Hinton quits Google so he could kind of talk about these things. Yoshua Bengio, one of his PhD students, who's one of the leading figures, also feels lost. But the key thing, and the public being surreal, but the key thing I think is this letter that was issued by Max Tegmark of MIT, by the Future of Life Institute, basically saying, let's slow down until we know what's going on. This was a complete failure. I mean, it's a bit like asking the leader in the Olympic marathon to slow down. Of course, you're not going to slow down because others will catch up. And asking Microsoft and Google, when they're competing against each other, to slow down is, of course, totally absurd. Now, I don't know if you've been watching the kind of, there's a soap opera going on right now in Silicon Valley. And there's Elon Musk suing Sam Altman and OpenAI over various things. Well, one of the reasons for this is that people are worried that they're so successful that we've got to the stage of artificial general intelligence, where AI is capable of outperforming us in almost every task. And it's going on and on and on. And so when Sam Altman was sacked from OpenAI, it's because Ilya Sutskever was a kind of whistleblower saying, This is crazy. No one's worried about the ethical side of things. We're racing ahead and no one's concerned about anything. Well, he's just resigned from OpenAI. He's given up. And we're just racing into a forward into a future where we've got no clue what's happening and no one is able to control anything. If you can't, in any case, if you can't stop Putin going into Ukraine, you're certainly not going to be able to stop Putin from using AI. So this is the problem that we've got to. Now, this has led to alarm all over the place. Yuval Harari, who's not an AI computer scientist, he's a historian and philosopher, but has a good grasp. He makes this comment that AI has effectively hacked our operating system, by which he means it's learned how to write, and therefore it has huge power, because once you can write, you can persuade people. It has effectively hacked our operating system. I would claim that it's also hacked our architectural operating system, because it's learned how to design. And I don't know how many have been using Midjourney and so on, but this is something I produced, and we're using version 5.3 a while back. And what's interesting about it is that, you know, I don't know about you, but I have huge prompts. I have 70 or 80 words in my prompts. And I refer to lots of things. I refer to the lighting conditions, the rendering, the hyper-realistic detail, and so on and so on and so on, all these things. But the actual references to architecture are almost non-existent. In fact, the only words I used to describe this building were ultra-contemporary, minimalist villa in the Austrian Alps. I didn't describe what the mountains should look like, what the valleys could look like. I didn't describe this boulder, this grass. I didn't even describe what the shape of the building was or the materials. Midjourney did it. Midjourney designed this, or this one, ultra contemporary stainless steel kitchen. I didn't tell it to put the painting in the background, which is quite a nice painting, or put the bushes and these things outside, or this coffee maker or whatever. Midjourney did it. Midjourney can design, not all the time, but it can design. And this, I don't know how long it would take to render this, but you know, this took 3 seconds. Don't look for a job as a renderer in the future. Those jobs will not exist. Now, if you thought that was a bit terrifying, this is even more terrifying. This is Sora, developed by OpenAI, and it hasn't been released yet. But what have been released are a few examples of what it can do. And people are being blown away by Sora. We've had image to videos since late 2022, but nothing like as good as this. Nothing like as good as this. And what you see, for up to 60 seconds, it can maintain a consistency. And in a few moments, you'll see a close-up, which shows you how astonishingly capable Sora is. It is remarkable. I mean, look at that. And this is basically a video version of a large language model. Instead of using tokens for words, it uses patches for videos, but it's trained on a vast, vast corpus of knowledge, and it's able to do these astonishing things. It'll come out in September, and I think around September anyway. Now, what is also a little bit alarming about this is that like large language models, Sora has also began to develop what are called emergent capabilities, emergent abilities. Just as large language models can translate text just by searching through the data that they've been trained on, and write code, again, just by searching through data, this is able to do certain things that it was not trained to do at all. For example, there's a term in the world of AI called occlusion. Occlusion happens when something goes out of the frame and then comes back up, back into the frame, and it's a technically very, very difficult thing to do. And certainly, this was not trained. Sora was not trained to do that. But if you watch this now, all of a sudden, this image will go out of this reflection and it comes back in again. And that was pretty astonishing in itself. But the thing that really gets me is the capacity for it to understand 3D. This apparently someone put their phone up and that you could recognize as a moorhen from New Guinea. This is beautiful in terms of the resolution, you know, the detail, the eye, and so on. It's amazing. But when it turns its head, you suddenly realize it has the capacity to really grasp 3D in an amazing way. I was talking about this in Manchester a couple of weeks ago, and there was someone there who had been testing out Sora, and he wasn't allowed to say anything. He couldn't say anything. He'd obviously written some non-disclosure agreement. But I said to him, I said, well, okay, instead of saying this is or this does, could you say something like this might be able to or could possibly, you know? And eventually I got him to acknowledge the fact that actually we're very, very close to getting to 3D, which is really the holy grail right now. How do we get to 3D? And it does it because of photogrammetry and because of the sheer volume of data. So we are on the cusp of shifting into 3D that is going to be a complete game changer in that kind of world. Now, of course, architects and interior architects will say, yes, but it's not as sophisticated as us because it can't design interiors of buildings and buildings. And until it does that, then we're quite safe. Well, oops, sorry, I'm going to go back a bit. But maybe not. This is Sora, and again, text to video. I don't know what the text was. No information has been released. Well, this is a video that probably took about 3 seconds to generate, and it's an interior design. So we had a discussion on Digital Futures about what future the metaverse has and design the metaverse. Patrick Schumacher said, no, well, it will always need humans to design the metaverse. And Wan Yu said, no, I think AI is going to be able to do it very, very well. I agree with Wan Yu. This is basically Sora doing an interior design. And I don't know what's going to happen when this is released and how it's going to change the way we operate, but we have to recognize that it's able to do these astonishing things. So there's been a lot of comments, a lot of comparisons between AI and human intelligence. Ray Kurzweil in particular has written a lot of books about it. I'm not sure I'm totally convinced by what has been said because it's rather generic kind of commentary. This guy, Geoffrey Hinton, though, as I mentioned, has basically got a background in neuroscience, and he doesn't make these sort of generic comments about intelligence or artificial intelligence or something. He's basically interested in the particular cognitive skills that are required. In other words, when you look at human intelligence, it's kind of based on a lot of different things. I mentioned that ChatGPT knows 10,000 times more than any of us. That's just knowledge. But understanding that knowledge is a different thing. And then you need to get towards thinking and then towards different forms of reasoning. And eventually you might get to consciousness. In other words, we have to be more particular. So let's just listen to why Geoffrey Hinton is worried about these things and their development.
It made me realize that these digital intelligences have something we don't have that makes them much better. When one of them knows something, it can tell all the others. That's what we don't have with people. So imagine you had 10,000 people, and imagine if when one person learned something, everybody knew it. You could learn a lot more stuff, right? And that's why things like ChatGPT knows like 10,000 times as much as any one person. It's because when you train it, there's lots of different copies looking at different bits of the data and learning stuff, and they can all combine what they learn instantly with a bandwidth of like trillions of bits.
So can they think?
Yes. So imagine the following scenario. I'm talking to chatbot and we talk for a bit and the answers it's given me seem a bit strange to me. And I suddenly realize that it thinks I'm a teenage girl. And I say, what demographic do you think I am? And it says it thinks I'm a teenage girl. So the question is, when I said I suddenly realized it thinks I'm a teenage girl. Was that a metaphorical use of the word think, or was that just the same way as we use think? And I strongly believe that use of the word think, when I said it thinks I'm a teenage girl, was exactly the same way of using think as we do with people.
And so that was enough to make you say, what, this has accelerated beyond my comfort level?
I suddenly realized maybe they already are better, and making them more like real neural nets isn't the point. They're already better than us. They're a better way of doing learning. And if we make them bigger, they'll get much smarter than us. They already know more than any one person.
I understand that things could go awry, but I still think that people hear the notion of danger and they dismiss it as hyperbole.
I thought it was hyperbole for a long time because I thought these things were a long way off. I thought there will eventually be danger, but I thought focusing on it now is unnecessary because it'll be 30 to 50 years before these things get more intelligent than us. But this combination of realizing that they might have a much better way of learning than we have, because they can share knowledge instantly, and seeing things like ChatGPT or Palm at Google that can explain why a joke is funny, made me realize these things are already pretty intelligent. And if they've got a better form of intelligence than ours, then it gets to be much more urgent.
So, I mean, just to clarify, when he refers to this joke, what he's basically saying, he asked Palm to explain a joke. Now, he figured if it could explain the joke, it must understand the joke. And he also thinks that basically if ChatGPT could answer our questions so intelligently, it must really understand the questions. The same goes for Blaise Aguirre-Arcos. Several people are thinking it's developing a form of understanding. I'm not sure whether it can think. I mean, typically when I wrote my first book, I said AI has got no more capacity to think than a pocket calculator. And then certainly if it can think, it has to be inverted commas. But nonetheless, what he's saying here, and it doesn't actually say it literally, but what he's saying here is, he says it elsewhere, is that AI has got a very different form of intelligence to human intelligence. It's a mechanical form of intelligence, not a biological form of intelligence, but it is far superior. It is far superior. And secondly, the other comment he's making is the way in which it can learn. Now, during COVID in the UK, we had a thing called the R number. And that's to do with the spread of the disease. If it was less than 1, it was good news. It was not spreading. It was disappearing. If it was more than 1, it was spreading. He's talking here of an R number of 1,000. It's basically, this could be an explosion of knowledge. So we're dealing with something that goes way beyond Moore's law, the traditional way in which we thought about exponential change. This is very, very rapid and very, very remarkable. Now, if you're worried about what he has to say, this is Yuval Harari, that should make you even more worried.
This is the end of human history, the end of human-dominated history. History will continue with somebody else in control. In 5 years, there'll be a technology that can make decisions independently and that can create new ideas independently. Maybe they'll be nice. Maybe they'll solve cancer and climate change, but we are not sure. I'm tending to think of it more in terms of really an alien invasion. An alien fleet of spaceships coming from planet Zircon or whatever with highly intelligent beings. This is what we are facing, except that the aliens are not coming in spaceships from planet Zircon, they're coming from the laboratory. If the humans are divided among themselves and are in an arms race, then it becomes almost impossible to contain this alien intelligence.
I think that term, well, I'm sure you didn't read my book, right? But that term is becoming increasingly popular, alien intelligence. I think it's useful because it really prevents us from anthropomorphizing this form of intelligence. So I'm just going to draw into the end now. This is, I gave a lecture last year in Warsaw. Nicholas Copernicus came from Poland. And of course, he's famous for the Copernican revolution in pointing out that the universe doesn't revolve around the Earth. Rather, the Earth revolves around the sun. I think we need to go through a second Copernican revolution and realize that we are not the center of intelligence in the universe. I think the problem has been that we've adopted a very anthropocentric view. We've been looking at AI in our terms, and we've been saying, well, it's not conscious, it's not self-aware, it's nowhere near as good as us. Well, if you were AI looking at us, what would you think? You would see a bunch of a race of people who are impossibly slow and really not very smart. So I think we've got to go and change our perspective and realize that we're in a different world, and this world is rapidly speeding up as we go. Anyway, just so you don't want to panic too much, I want to just play a bit by Arthur C. Clarke, who's very reassuring, who's basically saying, don't worry, it'll be fine. It'll be quite all right. So this is Arthur C. Clarke. What is remarkable about this particular video is that he made this in 1964, 60 years ago. It's as though he's talking about the 2024 that Geoffrey Hinton's talking about. It's remarkable how correct it's proved to be.
However, the most intelligent inhabitants of that future world won't be men or monkeys. They'll be machines, the remote descendants of today's computers. Now, the present day electronic brains are complete morons, but this will not be true in another generation. They will start to think, and eventually they will completely outthink their makers. Is this depressing? I don't see why it should be. We superseded the Cro-Magnon and Neanderthal men, and we presume we're an improvement. I think we should regard it as a privilege to be stepping stones to higher things. I suspect that organic or biological evolution has about come to its end, and we are now at the beginning of inorganic or mechanical evolution, which will be thousands of times swifter.
What I want to point out is what is going to save us is the fact that we human beings are really good at adapting. Neuroscientists say it's because we have a plastic brain, but we're very good at adapting to new tools, to new ways of operating and things. I mean, we can't even remember what life was like without a mobile phone. Can we even remember what it was like with fax machines? And there was a time, but it wasn't so far ago. And I think that's what's going to save us, because we will adapt. The future will be very, very different. There will be less work around. We will be operating in a fundamentally different way as designers. It'll be radically different, but we'll get used to it. We'll get used to it, and it'll just seem to be the new normal. So let me give you one example. If 50 years ago, someone had said to me that in 50 years' time, i.e. now, most marriages would end in divorce, I would think it's, oh my God, it's the end of civilization. The world's coming to an end. But that is the situation. Most marriages, I don't know about in Turkey, but most of the West do end in divorce, and we're quite okay with it. So I think the world will be radically different, but we'll get used to it, and we'll be quite okay. So I'm going to finish off on a very British note. Keep calm and carry on. Thank you.
Thank you very much, Professor Leach, for this very insightful and inspirational talk. I think everybody has a lot of questions, so I would like to give the floor to the guests. So do you have any questions who would like to start? If there isn't any, I have many. I took a lot of notes. So let me start then.
There's normally a huge number of questions after.
But I did my homework and I took notes, so I have a lot of questions. So you said in your presentation, stating that, I mean, if we don't use AI, we're not going to survive in the future. Even you said, do not design buildings, but design your futures for the students. So obviously the integration of AI in architecture will change the job landscape for architects. So how should I'm an educator, so I'm on the side of architectural education. So how should architectural education address the potential impact on employment, and how do you think we can prepare students for the evolving roles in the practice? What should we do?
I mean, that's a good question. I mean, what I would say is the first thing is to recognize it is an issue. And once you're aware if it's an issue, then you can begin to address it. And even if I can't necessarily give you a precise answer, well, what I would say is I've been giving talks all over the world, literally all over the world. And education worries me because when I talk to, for example, construction companies, I gave a talk at Turner Construction, the biggest construction company in the States. I gave a talk to Ferrovial, the Spanish giant. They are completely on board with AI, and they're changing everything they're doing. When I talk to architectural practices, leading architectural practices like Foster and Partners, they are radically overhauling everything that they're doing. Even some of those slightly sort of pompous organizations like the AIA and the RIBA, they're taking this seriously. I gave a talk to the 60 leading, or the CEOs of the 60 leading companies, or biggest companies in the States. I was expecting a bunch of people with bow ties that were frowning what I was saying and dismissing it. They were all nodding. They were all nodding. And education, I mean, it depends, of course. Obviously, this school is taking it seriously. Others, not at all. And that is super alarming, because we are the people who are kind of training the graduates for the future who are going to go out of this world of the singularity, whatever you're going to call it, it'll be a disrupted future. And to not teach AI, to not address these questions, would be a bit like me. I went to Cambridge, and we were told not to use computers in the studio. When the smart students would draw it on the computer, then they would do fuzzy overlay and pretend it was done by hand. And the weak students would just not use computers, and they were unemployable. No, so the world is rapidly changing. And frankly, I mean, I don't know this, but I'm told that in some countries, in some schools, there are some professors who are complete dinosaurs out there who were, they studied Le Corbusier 30 years ago, and they're still talking about Le Corbusier. The one example that Joseph Rickbert once told me was there was a professor once who, when he first started, would pack out the auditorium. And in the end, there were only about 4 or 5 people in the front row, and 30 years later. And he said, I don't understand this because I'm teaching exactly the same material that I used to. I mean, that's the point. The world is evolving. Practice has to adapt. It has to adapt. Construction has to adapt. And of course, the architects will have to adapt. And it's absolutely zero question about it. And if I can just give you an example of a practice that has adapted, I mentioned Güvenç Özel, is a Turkish architect teaching at UCLA. He's got a practice with 4 people. They are winning competitions against the big guys, against, Gensler and so on. Now, if they're doing that, I mean, I know that Gensler, because I've got a student working with Gensler, they're also taking it very seriously. But that's the future. That's the future. And if we can get on board with that, we will have enormous opportunities, enormous opportunities. And one of the areas I would say that I think that architects in the future will have opportunities is I think we can redefine what our role has been. I think in the past, we've only been able to do certain amount because that's all we can do. With these tools, they open up new areas. I think, for example, Xcool, their software is basically designed for developers so they can understand how to operate. Well, we could use that. We could become developers, and instead of being the bottom guys on the pay salary, it's always the developers at the top, and there's the quantity surveyors and the engineers and the architects at the bottom. Yeah. We could be redefining ourselves. So it is full of opportunities, but you've got to be really ready for it. And frankly, if schools of architecture are not addressing this, and some of them are not, it's a disaster, a total disaster. I'm really quite worried about that.
Oh, okay. It's nice that we are at least trying to do something, maybe at the beginning, but as our dean said, we organized the workshop, and we somehow, try to students push a little bit to use those tools even more. Any question? I'm looking to the room.
One down here.
Yes, please, Hajam.
It's my board. Okay, thank you. Professor Leach, thank you for this presentation. I think it was quite interesting and informative for the students. As an educator, also, we are discussing among ourselves how this AI will extend to education in terms of also ethical implications. How it will reflect what should we do, how we should limit students if we have to limit at somehow. And especially as a researcher who works mostly on sustainability and building physics, so I have to combine these 2 questions all together. In what ways do you think AI can enhance sustainability and resilience in architectural design? And what are the potential ethical implications on relying heavily on AI intelligence in this field, particularly about sustainability and resilience?
Well, first of all, the ethical question. There are lots of issues, and I'm not sure that everyone's fully aware of the complexities involved. We try in Digital Futures to have sessions discussing these things. First of all, let me say copyright has become a kind of key issue, but I think a lot of people misunderstand that the nuances of what copyright is all about. It is not so straightforward. One thing we discovered is that you won't be able to sue these companies very easily. It'll cost you a 6-figure sum. It'll take you 3 years before you get anywhere. That's not necessarily, and I think it's not clear there is any what copyright infringement there is exactly, unless it's deliberately scraping copyrighted material from the web. That is a clear infringement. But elsewhere, I don't think it's so clear, and I don't think that the courts are going to come out and stop these tools, because they're very useful tools. There are other issues, like, for example, bias, and what we're discovering is that these tools are spewing out, you know, race talk and really unfortunate things. But the important thing to recognize, that comes from us. It's not as like it's got something inside AI that's deliberately doing it. All the data it's based on is coming from us. So if you go to Google, and if you Google nurse, chances are almost everyone will come out as female. Likewise, if you put in architectural professor, you probably wouldn't get the range of female professors you've got here, you know? So it's coming from us. And I think if anything, we could probably recalibrate a machine, but recalibrating human bias is less easy. But there are these concerns. But the real problem, I think, frankly, is how do you enforce them? How do you enforce? I mean, we've discovered that you know, we can't stop Putin invading Ukraine. So how do you enforce anything? And that's the real challenge. I mean, but these remain. I think one of those concerns also is the question about environmental systems, because at the moment, at any rate, these systems are using vast quantities of energy. Even if you were to Google something, a word, every time you Google, you use up enough energy to make a cup of tea. I mean, it's that extreme. Having said that, I think that, you know, that really they also offer a way forward, in the sense that I'm sure they'll improve the energy efficiency in themselves, but they can also be used to be efficient. So I think that the future probably lies in what's called digital twins. There are different interpretations of digital twins, but my version of digital twins, where you're using AI to really improve the performance. There's a guy at Harvard, Ali Malkawi, who's actually refitted an existing building with all these sensors, and they're looking at and they're using those to really improve the performance. And they're using AI as a digital twin inside that, you know. And I think from that perspective, and I think we'll also be using, they already are using digital twins to improve the performance of cities, especially traffic. That's been used in China. There's a company called CityBrain doing that, and I think that's the future in many ways. So what I always say is actually that the future is not going to look much different to today. I published a book in 2009, Digital Cities. And it was full of Patrick Schumacher talking about the parametric city, right? Well, we haven't seen that, actually. We've never seen that digital city. My view is that, and at the end, there was a very interesting article by Ben Bratton that I thought was far more appropriate. All the architects were saying, this is what it's going to look like. This is what's going to look like. What Ben Bratton did in his article was called iPhone Cities, to say that this device, the iPhone, has changed the city more than any architect has. You know, I think the future is going to be all about information, informational systems, and how you control things using AI to make them more efficient. And it's not a question of form. It's not a question of form. So I would give you one example. You know, I don't know, Mario Carpa is always trying to predict what things would look like. I mean, and the future of AI, it's not going to look different. If you look at an Uber car, does that look different to an ordinary car? No, because it is an ordinary car. It just operates in a very sort of different way. So we have to be looking at information and performance and things rather than the form itself. And I'd also be a little cautious of those who, I care for what I say here, because maybe you're a friend of his, but I mean, people like Stefano Boeri, who think that maybe the future is what he calls the Bosco Verticale. You have a tower block and you just put plants and trees on the balconies, and that's going to solve the problem. That doesn't solve any problem. By comparison, I was at a conference in Kitzbühel in Austria, where there was a guy who did a PhD at ETH and had been working on AI and ship design, boat design. He'd been part of the America's Cup, which they use obviously very progressive technologies to design these super yachts, as it were. But he also now working on domestic boats and ships and things, and on sort of commercial boats and ships. And what he says is that they don't sketch anything. They basically use AI and base it on data, and the AI generates the form. So it's informed by performance concerns. It's not the old-fashioned let's sketch it and so on. So I would say that the important thing is to be able to harness the intelligence of AI to inform the performance of the building, and also the design, also the performance afterwards. One of the things that is clearly becoming a case, because Autodesk are moving into that, is post-construction performance, and trying to look at that very closely. So hopefully it'll be less consume less energy, and hopefully it'll help us consume less energy. But I think in every area it should be able to enhance our intelligence and to make us operate much better. Yeah.
Yes. Okay. So I wrote some things, Hocam. Firstly, I would like to thank you for your presentation. It is shocking how AI can do things. We can all agree that AI is far more superior compared to humans in terms of rational operations such as playing chess, finance, and math. It can do these operations properly since they are rational and they are based on an algorithm. For example, moves you can make and strategies you can use in a chess game are already determined. In my opinion, it lacks on the design part, Hocam. What I mean by the design part is design means the reflection of ideas. It is not the form, it is not the looks, it is not how it places something on a site. AI doesn't think, it doesn't create, it merely mimics and rearranges data provided to it. Therefore, I do not think AI can function properly on its own, meaning it cannot be an architect, but it can be an architectural assistant. For example, AI can make forms, volumes, diagrams, beautiful images, but those things are not architecture. Those are just some rational things that appear in architecture. And for the sustainability part, AI is like not sustainable at all, in my opinion. And according to research I did, like the chips that they use, NVIDIA provides the chips for that. And they waste a lot of water producing those chips. And in order to make that things, go on, in order to maintain those operations, it requires too much energy, and it's not very sustainable at all. And you mentioned the Google example. It also is not very sustainable, if I remember correctly. And what do you think? How can we improve the design part, the idea? It cannot think, can it? Like, am I wrong?
Well, I mean, when I mentioned the thing about sustainability, I wouldn't be so sure or confident at all. The real issue is I mean, I'm trying to say, and I was trying to say, well, let's step back and see things how it might see it, right, as it were. If it can beat us at a game of Go, now you said it's just rational, but Lee Sedol thought it was being creative. I think it was just being rational. But then I would question, what on earth does this term creativity mean? We use it a lot. It was invented in 1929. That was when it was coined, and it's a very new term. And I would say there's a danger of mystifying. Oh, it's so creative. What do you mean by that, right? And I would compare it to the term magic. Oh, it's so magical. No, there is no such thing as magic. You see a magician, and it's a trick, a magic trick. You're not actually, he's just concealing, he or she's concealing what's going on. In fact, Arthur C. Clarke says that, any sufficiently advanced technology resembles magic. And he also says that, basically he said that whatever we can't understand, what science has not explained yet, appears to be magic. I would say that creativity is simply whatever's happening. We haven't begun to explain it properly yet. And I would say our problem is the opposite. We're not as good at selecting, as objective, as rationalizing as the computer is. And when we say we come up with all these expressions about valorizing the human, I don't think we're good enough, frankly. And I think that we need to be more humble and understand there are other techniques. Would we compete against a calculator anymore? We wouldn't, no. And I think fairly soon it's going to be operating in the cultural domain. I mean, you could say that the translation of language is itself a cultural act, right? Rather than a rational. It's better at translating than we are. My book's being translated by AI right now into Chinese. I think we need to step back and question some of those things. I think, if anything, what AI has been to me has been a mirror in which to understand what it is to be human. And it's told me a lot about some of the things we've taken for granted. The more you interrogate these things, the more you begin to realize that they're a little bit suspect, and we can interrogate them further. So that's what I would say. I'm particularly interested by the world of neuroscience and what these guys are saying. I don't know if you've ever watched, say, the TED Talk of Anil Seth, Anilseth, because he's incredible. You know, this is a guy, and actually he did a PhD in AI before going into becoming a professor of neuroscience, but he's basically saying that we are hallucinating our reality, that what our view of the world is a complete hallucination, a controlled hallucination, but a hallucination. And once you begin to realize that, some of the things we say with such authority now about this being a genius designer and so on, you know, I think that will all be called into question. And I think that in the future, the way that we will design is be very different. It's not going to be like inspired by God and here's the sketch. It'll be, well, already we're seeing that actually with an algorithm, with algorithmic design. You create a search space and you generate some outcomes, and then you select from those outcomes, often based on aesthetics, but it's still that kind of thing. In which case, we're changing things. We're not being this genius curator. We're actually curating in some extent, you know. And I think that's what's happening with Midjourney. Even, you know, you have to have a good eye to be good at Midjourney. You've got to know what to select. But basically, we're curating to the point that theorists like myself can be designing again. And I think that whole world is changing, and we need to really question things. We need to change the lexicon, the words that we use, because maybe it won't be designing, it'll be generating in the future. Maybe it won't be a design, it'll be an outcome, and so on and so on. And I think that it probably makes more sense to be a little bit more humble and to really recognize our limitations. That would be my view. I understand that people get upset about all these things. I mean, I wrote an article once when someone wrote something and said, "Oh, AI won't affect employment." And I said, "What do you mean? You know, it's obvious. Everyone's telling this." And there was one person that got two responses. One from those who knew AI and said, a little bit uncharitably, you know, "There's nothing new here." I think there was something new in what I said, but there was another group of people who were completely pompous. There was one guy who said, "There's not a single AI on the market that could possibly match my ingenuity and creativity." Well, that guy is going to be the first to go, right? And I think we need to be a little bit more humble and recognize this, and some of the obfuscation of the terms we've used. I would say that. I'm not quite sure the answer to that, but I would say we need to question some of the assumptions that we've had personally. And well, the sustainability thing, hopefully it'll be resolved, but I don't know myself.
Okay, can I add another question?
Yeah.
Maybe. So we were working on an O-level production facility and in a studio work. So on the data part, for example, let's say design an olive oil. Let's write a prompt. Let's say design an olive oil mill to ChatGPT, maybe an advanced one. So it will design olive oil mills according to the data provided to it, right? According to it will check for old olive oil mills and try to come up with a design, right? So there are some data that cannot be found on the internet on the site I noticed. For example, there was a place called Balkaya, but it didn't even exist on the maps, on the web, anything like that. It was in the traditional folk, in speaking cultural language thing. So like using AI for as an architectural assistant is like very cool. Actually, I'm using it nowadays. But on its own, like, do you think that it can do the job architects do, like, properly, or?
I've got no question. It's eventually going to be able to do that. I mean, I think there's a difference between this Midjourney stuff, okay, and that is just images, right? It does no sense of performance at all. You know, I've tried it, tested out, but it doesn't really understand more than that. And I think that's why I'm saying that the data-driven optimization, which is like the way that they're designing these ships these days, it's based on that. That will be the way forward. So I mean, what it doesn't have is any intentionality. It can't make decisions of its own at the moment. But it's probably gathering data on what we like. I mean, certainly Amazon knows what books I like. Spotify knows what music I like. My phone knows what political commentary I like, and it gives it to me. And I'm sure it'll be able to detect what architecture I like and do that. So for the moment, we're in charge, and it is an assistant, a prosthesis, I say, but eventually it could well be capable of doing that autonomously, which I finished my book on. Amazing, right? Fantastic. Well, what happens then? Once you've got a self-driving car, you don't need a driver. And once you've got AI that can generate designs, then you don't maybe need a designer as such. But I think it's important rather to try and think of, to my mind, what we need to do though is to try and use our architectural imaginations to really imagine scenarios where we can harness these tools in different ways. And that doesn't mean making a sexier form than Zaha. It means really using that imagination. For example, I think that architects are very interesting because we do little diagrams, which means we kind of trying to visualize what we're thinking. No one else does that. And I've often noticed that actually architects are able to imagine systems that others can't. I mean, the designer of TED Talks was an architect, and Digital Futures, which is quite complex actually, was designed by me. And there are other things and I think that's where we should be harnessing our imaginations to try and find different ways of deploying our intelligence, not sexy forms, but understanding systems. That's the future. So, I mean, I wouldn't take the view it can't do this and it won't be able to. I'd say, what can we do with it now and get ahead of everyone else by really thinking ahead of the game? I did a book which your dean has, Rethinking Architecture, back in 1997, and I remember people saying, that'll not sell. No, it's going to be just a fad. It'll go out of, that book's still selling. And the way I it was basically a collection of essays on architecture by philosophers. I think now it should be neuroscientists or something. And I recall when I was doing that, for me, it was a question of putting my head on the line before anybody had made that line. That was how far you had to think ahead. And I think that's the same thing now. No one's drawn the line yet, but imagine where the line will be. Put your head on that line and commit yourself to that. Those are going to be the people who are going to survive in the future, who are very able and very quick to adapt and to see opportunities. Not to say this is the model of the past and it can't do it yet, but rather to think, what are the models of the future? How can we be more inventive? How can we use that architectural imagination to really do things in a different way? So that would be my thinking. Yeah.
Thank you for your answers, John. I also want to thank you for taking your time to come up here and giving a proper physical speech, unlike other digital ones. Thank you for that. That means a lot. Yeah.
Hello. Thank you very much for this inspiring speech. I'm curious about your take on the embodiment issue in the artificial intelligence realm. To explain my question further, the data that the AI models work with are quite disembodied. And my critique comes from a more phenomenological perspective, I guess. And one of the inspirations behind this question is the Hubert Dreyfus's book, What Computers Still Can't Do. But it was a critique of symbolic AI, but the critique of embodiment and disembodiment, I think, still holds. And as designers, we have a lot of different types of reasoning synthesized in our work, or as human beings in the way we inhabit space and create space and think. So I'm curious about your take on this this issue.
Yeah, I'm not an expert on that at all, although I do know people who are. I think that, I mean, maybe I could just approach it a different sort of way. I think that it actually, rather than using the term embodiment, certainly context is actually quite significant in that what they discovered is all the data that has been kind of scraped from whatever, it all has a context in an interesting way. And so when you get, I don't know if you've been using these prompts, but the prompts are actually, it's not rational. You have the expression that is called, prompt engineering, which gives the sense it's very, very rational and very logical. Actually, prompts are like alchemy because they're all based on all sorts of contextual information that really muddy the waters. I first discovered this when someone told me to do, asked me to do, suggested I did a house extension. So I would put the word house, the two words house extension in my prompt. And then I thought, this is very strange. I'm getting British buildings and gloomy weather. And then I discovered the word house extension is only used in the UK. And there's, I'm blanking on his name now, but who is that Mexican architect who has beautiful colors? Barragan, yeah. You put Barragan in there, and of course you get Barragan's color, but then you also get Mexican plants, Mexican sunlight, Mexican, and from that point of view, it's kind of the information is kind of very much contextualized, and it's associative and it's logic. And actually, and this is where what I find interesting about AI is actually what it tells us about us. And we actually think in a very associative way ourselves. We tend to think we've got different senses. I mean, the phenomenological tradition would say that, oh, we privilege the visual, and actually, what about the other senses? But I would say that vision is ideational; it's a vehicle for other things. If I look at a Turkish cake, I know what it's going to taste like roughly, or a fish, or if I go up to a door handle, I know roughly how cold it's going to be, how stiff it is, how hard it's going to be, because all these things are working through association. If in my kitchen I see a red hob, I don't know not to touch it because I know that red is hot. And I think we work in that sort of way. So, and that's the argument that's been made by Blaise Gueriakos to say that actually, so this material is in some senses contextualized. Whether you could say it's embodied or not, I don't know. I think that the real problem has been in some senses people saying that AI lacks this, lacks that, and it's true in some senses. I mean, some of my students have clearly gone to ChatGPT, and ChatGPT says that AI lacks empathy. It hasn't got this what we humans have got. Well, then I had two students who they all do movies for me, and they produced a movie, and they said actually, it can simulate this very, very well. And there are certainly people in MIT Media Lab now, Behnaz Ferrari is just joining them, where they simulate emotions. And I think the problem is actually the opposite. Not that AI's got no emotions, but rather we're going to be in a situation like that movie, Her. People will be having relationships with their AI and God knows what else, probably having sex with robots and things, I think that's the problem. It can simulate those things. So I think it's dangerous to go and say, we fall back on those sort of models. I mean, I have to say that I've got a little bit of a kind of how could I put this? Oedipal complex, Oedipal situation towards murder the father, murder the mother. I was taught at Cambridge where we were given all this phenomenology, right, and told not to use computers. Dalibor Vasley was going on about Heidegger, and I was once invited later on to write about technology for the school in their magazine. I said, no, I better not do that because it'll be too controversial. Anyway, eventually they persuaded me. So yeah, I wrote this thing, and in a very phenomenological way, the title, or very Heideggerian way, the title presented itself, like Forget Heidegger. And Dalibor was furious. He said, I can write a very short essay, Forget Leach, very easy. But then I produced a book called Forget Heidegger. I think we got to move on from those things. They're a little bit nostalgic. And that's why I think that neuroscience is really the new paradigm we need to be focusing on. And it's not that actually there are some neuroscientists, I'm blanking on the name of the guy from Chile who talks about, but who deal...
Maturana? Umberto Maturana, I think. Is it?
No, it's someone else. It'll come back to me. And also, frankly, psychoanalysis. I mean, much of my work has been about psychoanalysis, but Freud only supposes there's an unconscious. It's not really kind of tested out. And I've been just blown away by some of the neuroscientific discourses, which I won't get into now, but they're super interesting. So I find that world a little bit nostalgic myself. But then again, I'm a bit of a, I don't know. Someone once, when I gave a lecture at the Bauhaus, when I first started teaching there, they put a poster up there, and it was in English. It described me as an architectural theorist. And the technician, who couldn't speak any English, read the poster. He said, "Architectural terrorist." So I'm a bit of a terrorist when I come to. I like provoking people and coming up with things, but I think it's important to provoke, important to ask questions and challenge people, so you don't just get too cozy in your assumptions.
Thank you.
Thank you for the speech, but I feel like you are more on the optimistic side right? But you started with saying, giving the analogy of kitchen knife and terrifying kind of words. What are your fears? I'm curious about this, if you have.
I was careful not to say my fears because, I mean, the students are graduating. Maybe the students have all fallen asleep now, gone home or something. But so, I mean, first of all, you're right. Or at least ChatGPT thinks you're right because someone asked it, am I more positive or negative? Right now, I'm 66% positive. And you know, so maybe I am. My fears are, well, no, I think the final comment I was making, we will adjust. I think that's the important one. I wrote a book called Camouflage, which is all about how we adjust, adapt. You know, I'd be moving around hotel rooms the whole time. After one night, I get used to a hotel room. Then I get used to it. I get used to it. We're very good at adapting. And I think that is the case that, but it is, I think, okay, to my mind, maybe all the students here can block their ears, but to my mind, the real danger is this. I mean, I mentioned my friend Guvench Ozil, who's got 4 people, they win these stadia, these competitions and things. Now, the real problem financially for architecture is that largely the fees are based on a percentage of the building cost. Now, if things get tough and someone's undercutting someone else and saying, oh, I can do it, instead of 5%, I can do it for 4%, 3%, 2%, whatever. That's a real problem because there are going to be no more buildings. In other words, the amount of money coming into architecture is going to be based on a percentage of the cost of the buildings. And if there's a kind of race to the bottom, that means if it's 2% rather than 5%, that means there's 40% less money coming into architecture. And I think there's already a problem in architecture. Someone was telling me when I was in Brighton that he can't afford to pay anyone more than 35,000 a year. That's all he can afford because the clients are paying less. They're paying less. And now they're also saying, you're using AI, I'm going to pay you less because it's doing all the work for you. So there is a danger that we're going to be in that situation. And what the impact of that is, it's already happening in China for different reasons. Their fees for some of the bigger buildings are just 1 or 2%. And it means that there's so little money in architecture. Nobody wants to go into it. The cultural capital of architecture is collapsing and people are doing other things. It's easy to get a place in Tsinghua or Tongji now compared to what it was like 10 years ago. And that, I think, is my concern, that cultural capital will go down. That's why I'm thinking, but I think there's hope with those people who are really imaginative and how they can deploy these systems effectively. And I think there are opportunities. One of the things you can't predict is the way in which people use things, like the mobile phone. The fact it was designed for rich businessmen, and then when they gave the phone to their daughters, that changed the social use. And the way in which people are going to be using these tools inventively, I think I'll keep the term inventively rather, but not maybe junk the term creatively, but inventively. I think, you know, there's hope for something new to come out there. And I think on the whole, it is going to be incredibly good for civilization, for science and medicine in particular. This is going to really lead to enormous breakthroughs. And I think also, I mean, maybe it's not the world of a construction site, but I think for worlds like the history and theory, history, you imagine you've got all that data, you'll have access to far more potential information in terms of how you interpret the data than in the past. And certainly for theory, it's beginning to kind of, it's certainly asking really good questions. I was giving a lecture in Melbourne a few weeks ago, and there was one of my former students in the audience had some AI app that was listening to my conversation, and it came up with this incredible question for me at the end. I think it's going to enhance every aspect of what we do. It's just that we need to really adapt to survive. Otherwise, we'll turn out to dinosaurs. We'll be sleepwalking into oblivion. So it's a difficult question to answer, your thing, but I'm worried that well, architecture, I think, is going to collapse, but other things might come out. You know, I think, for example, I don't know. I've got a friend who's recently offered a post at MIT Media Lab, and and Harvard was saying, oh, we like our architecture with a capital A. We don't like the Media Lab. And that's the wrong direction, because all the students at Harvard were all doing courses at the Media Lab. At the MIT, they've now got a thing called the Morningside Academy of Design, which is all the design fields together in one platform. And I think that's much more creative. I've noticed from my own publications that architects actually have got many marketable skills. You know, we're taught just to design, but actually we can use those skills elsewhere. Increasingly, we're opening up into that. So one of my books was called 3D printed body architecture, where I noticed all these architects working for Iris van Herpen, people like Neri Oxman and so on. And, you know, we can do that. We can do that. In LA, everyone's doing 3D printed food and God knows what else. I also did a book on space architecture, because I noticed there are so many architects working in the space industry, you know, and I think we have these skills that are deployable skills that we can use elsewhere. So I would say that probably the future of education is to try and create some kind of unified platform where we cover all these skills, and then allow for some diversification. You might specialize in architecture or construction management, or, you know, in interactive design or interior design or whatever. So, but I think we have to adapt. We have to really seriously adapt for a world that is rapidly changing. And I think the biggest problem, in some senses, I'm saying that we adapt, but we don't adapt as quickly as AI does. I mean, that's very clear. It's really very quickly adapting and learning and changing. Anyway, so I'm 66% positive.
So, thank you very much. There's a cocktail going on. Waits for us. So let's continue with the discussions and the questions there in that more informal environment. We have a very small gift for you. Thank you very much for your talk. I mean, this is a plant. Oh, okay. Yes. Yeah, it is planted by your name in Yaşar University woods. Oh, this one, yeah, really? You just use this code, and you're going to find where it is. Oh, really? Yes. Wow. That's the kind of traditional gift that how it is. Thank you. Thank you. Thank you. I will look it up. Thank you. So, our guests, you can just join the divergent outside. Thank you for coming.